Okay, so we're going to continue on with question number 21. It says assume that x has a normal distribution and find the indicated probability. The mean mu is equal to 60 and the standard deviation is equal to 4.0. Find the probability that x is less than 53. So we have a normal distribution, we have a mean of 60, and we want to find out what's the probability that x is less than 53. So we're looking for the area to the left. Whenever we're trying to find area, we're using the normal CDF. We could convert our x values to z-scores and then use those z-scores, but in our example we're just going to use the x values. Our area starts to the left, so we're going to start with a very negative value like negative 10,000. We're going to go up to 53 and then enter in our mean and our standard deviation, which is 4. So looking for the area over here, we're going to go second bars, normal CDF, starting with negative 10,000 and going up to 53, and then our mean is 60 and our standard deviation is 4, and that gives us a total area of 0.0401 if we round it to 4 decimals. Alright, that's number 21. Number 22 asks us to find some critical values. So do one of the following as appropriate. Find the critical value z alpha half, find the critical value t alpha half, or state that neither the normal nor the t distribution applies. So we're going to check our requirements over here. We need to have a sample size greater than 30 or a normal population. So over here it says 98%, sample size is 7, sigma is equal to 27, and the population appears to be normally distributed. So since our sample size has to be at least 30 or a normal distribution, we know that we can use the t or the z distribution. So that's the first one to check the requirements. So yes, we can use, either one, the z or the t. Then we're going to look at what's given over here, and we know that sigma is equal to 27, and sigma is the population standard deviation. So since we know the population standard deviation, we are going to use the normal distribution or our z-scores. So we know it's a z alpha half, first of all. Then we're going to draw it over here. We have 98% or 0.98 in the middle, which leaves us 2% in the two tails or 1% in each tail. Now we're going to use the inverse norm and add the two areas on the left, so that's 0.99, and that will give us the critical value. So using second bars and inverse norm of 0.99, and that's a standard normal distribution. We're looking for z-scores. You hit enter, we round z-scores to 2 decimals, so it's 2.33 over here. So our answer would be C. It's a z-score. So the critical value is a z-score and the value is 2.33. Alright, that's number 22. Now 23, we're supposed to find the area of the shaded region. The graph depicts IQ scores of adults, and those scores are normally distributed with a mean of 100, that's our middle value here, and a standard deviation of 15, as on the Wechsler test. Okay, finding the area between 85 and 125 means we're going to use the normal CDF. We can convert our x values to z-scores and then use the tables or use the normal CDF. Or we can just put in our lower x value, which is 85, and our upper x value is 125, and then enter in our mean and our standard deviation is given above, and that will change our x values to z-scores, and then it will convert the z-scores to an area. So using the normal CDF, second bars over here, and going from 85 to 125 with a mean of 100 and a standard deviation of 15, gives us a total area of 0.7936. Okay, and the closest value over here is 0.7619. Actually, sorry, no, it's C, 0.7938. Obviously, our value is going to be a little more exact since we've put in the exact numbers. We don't, if we convert them to z-scores and then, round those to 2 decimals, it would give us a slightly different answer. All right, so just a couple more questions over here. Number 24, find the area of the shaded region. What you notice over here, first of all, that this is symmetric. Your mean is 0, and it's also given up here. Mean is 0 and standard deviation is 1. So that's a standard normal distribution. We are looking for an area, which means we're going to use the normal CDF, put in our lower z-score, where our area starts of 0.59, put in a very large upper value. For example, we can use 10,000. This time, we just leave the mean at 0 and the standard deviation at 1. So second bars, normal CDF, going from 0.59 to 10,000. And our mean is 0, our standard deviation is 1, hit enter, and we have an area of 0.276 rounded to 4 decimals. 2776. Okay. And that is answer D over here. Oh, hold on. I circled the wrong D. I skipped a question, so 0.2776. Okay, moving on to question number 25. Assume that a sample is used to estimate a population proportion P. Find the margin of error E that corresponds to the given statistics and confidence level. Round the margin of error to 4 decimals. So we're not looking for a confidence interval, but we're actually looking for the margin of error, which means we're going to have to calculate it manually over here. We have 95% confidence, we have a sample size of 380, and our number of successes is 50. Okay, so and our confidence level is 95%. All right, looking at a population proportion, our margin of error is defined as z alpha half times the square root of p hat times q hat divided by n. So let's find the z alpha half, and then we're going to look for the p hat, the q hat. 95% confidence means 0.95 in the middle, which leaves you with 5% on in both tails, or 2.5 in each. So we're going to put 0.25, that's 2.5%. Then finding our critical value, which is the z-score over here, we have to add the two areas to the left. And then we're going to take the inverse norm of 0.975. This is one of the common ones we've used. So of 0.975 is 1.96. So it's one of the one that's given on your formula sheet. So E is 1.96 times, what is p hat? Well, p hat is x divided by n, so it's 50 divided by 380. And we can actually simplify that. That's 5 over 38. or it's approximately 0.1316. Now, the more decimals we carry, the more accurate. Q hat is just 1 minus that number, so that's 0.8684. So let's multiply over here the P hat times the Q hat. That's 0.1316 times 0.8684 divided by the sample size, and our sample size is 380. So we have 1.96 times the square root of 0.1316 times 0.8684, and all that divided by 380 is equal to a margin of error of 0.03399. And then we rounded to 4 decimals, so that means our 9 actually gets rounded up to a 10, which makes it 0.0340, which is answer A. Alright, I'm almost off the page right here. Okay, going on to question number 26. It says the shaded area is 0.0901. Okay, this time we have an area given. We're trying to find an associated z-score. So finding the z-score, we're going to have to use the inverse norm of 0.0901. It is a standard normal distribution with mean 0 and a standard deviation of 1, so we don't have to make any adjustments there. Using the second bars, going to inverse norm and entering our area, 0.0901, leaving mean as 0 and standard deviation as 1. And our z-score rounded to 2 decimals is negative 1.34, which is D. Alright, so we have one last question over here. It says the Precision Scientific Instrument Company manufactures thermometers that are supposed to give readings of 0 degrees Celsius at the freezing point of water. Test on a large sample of these thermometer reveals that at the freezing point of water, some give readings below 0 degrees Celsius and some give readings above 0 degrees Celsius. Assume that the mean reading is 0 degrees Celsius and the standard deviation of the reading is 1 degree Celsius. So what does this sound like? It sounds like we have a standard normal distribution with mean 0 and standard deviation 1. Also assume that the frequency distribution of errors closely resembles the normal distribution. A thermometer is randomly selected and tested. Find the temperature reading corresponding to the given information. So find P40. So we have a standard normal distribution. Our mean is 0. And we're trying to find P40, which separates the bottom 40%, which is also 0.4, from the top 60%, which is 0.6. Okay. We're looking for a z-score that's associated with an area, so we use the inverse norm of 0.4 to find it. So the second bar's inverse norm, an area of 0.4, standard normal distribution, gives us a z-score of negative 0.25, rounded to 2 decimals. And that is answer choice D over here. All right, that is the last question and concludes our review.